Hello everyone, welcome to the Spin Tangle. Today, it's the last lecture of this statistical mechanics section. It is titled as Phase Transition. So, let's start this topic. What is called a phase transition? Phase transition is the transition between two phases. Okay, I'm writing this transition between two phases. Okay, what is phase here? Phase means nothing but state. Say you are in a state, solid. Okay, say a matter is in state solid and it will become liquid after some time. Okay, after applying some heat here. So this is called a phase transition. Okay, state change is called phase transition. Nothing so serious about this thing. Okay, so say you have solid and you are directly this solid is directly going to vapor. Okay, directly going to vapor. So this is also a phase transition. So what is solid to liquid? It is solid to liquid. We know it is called melting. Okay. Okay, and liquid to solid is called also freezing. You can write this thing, liquid to solid. Okay, and solid to vapor is called solid to directly vapor is called sublimation. Sublimation. Okay, and the opposite is called the vapor to solid, directly vapor to solid is called deposition. I think so, deposition. Okay, and also these are the examples of phase transitions. Okay, examples. Any other example is there? I'm giving an example. Say ferromagnetic to paramagnetic transition is called phase transition. And say you have a helium 1, say 1 helium means this is called orthohelium. Okay, orthohelium to perihelium transition is also an example of phase transition. Okay, helium to say perihelium. Okay, normal conductor, I'm giving many examples. So here say you have normal conductors or ohmic conductors. You can write this thing as ohmic conductors, the conductors which follows Ohm's law. Ohmic conductor to superconductor is also a phase transition. Okay, so first let's understand the phase diagram. What is called a phase diagram? Okay, phase diagram is a diagram in which the three phases of a material is located. Okay, so I'm drawing this phase diagram here. The phase diagram will look like this. So give an heading called phase diagram. Okay, a phase diagram. The phase diagram looks like this. Say this is if I have, say this is, and you have another say at this point. This is called phase diagram. I think if you are studying in BSc Physics, so you are familiar with this picture. Okay, so This region is the first. Oh, sorry. Just wait. Here is P, and here is T. That is, here is pressure and temperature, and pressure and temperature causes this region is solid state. This is called solid state, and this is the liquid state. Okay, and this is vapor state. Solid, liquid, and this is vapor state. Okay, this is what this is the meeting point of these three curves. Okay, the first curve is called even this thing, this curve, this is called the melting curve. This curve, the melting curve. Okay, this is called liquid to vapor, is called vaporization. This is called vaporization curve. And here, vapor state to solid state, this is called sublimation. Not just wait, solid state to vapor is called sublimation. Sublimation curve. Okay, this is melting curve. And the very end of the graph, there is a certain point called, this is called the C. Okay, this is called the critical point. So we have 2 points, 2 emergency points. This is one emergency point, this is one emergency point. This point is called triple point because the 3 curves are meeting at this point. Okay, triple point. And this is what this is called critical point. So let's define what is a triple point. Say first define triple point. The point where all the 3 states of the material coexists, okay, in equilibrium. Is called triple point. Say you have a material and the material can coexist in this point. Say in the triple point, the three curves are meeting at this certain point, so this point is called triple point. Okay, so the 3 states, just wait, this is I've given. Okay, and triple point. And now the critical point. What is this? Is an important point. Critical point. The end point of the vaporization, the end point of the vaporization curve is called critical point. Okay, so if I have to remember one thing, now I'm moving to the types of phase transition. Not to remember anything, just 1 second. Okay, this is I'm directly moving to the type of. This lecture is completely based on the questions which had been asked in various competitive examinations. From the basis of these questions, we are not going to a very deep understanding of these facts. Okay. This is completely based on the competitive purpose. Okay. Types of phase transitions. Okay. There are two types of phase transition. First called first order phase transition. Okay, and the second one is called second order phase transition. Okay, so I am moving to the first order phase transition. What is our first order phase transition? First order, the phase transition, I'm giving a definition. Okay, just wait for a while. The phase transition in which the Gibbs free energy G is continuous and the first derivative of not and just wait this is comma here. The first derivative of G is discontinuous and the second derivative, second order, you can write these things, second order derivative, I'm writing second derivative of G is diverging at transition point. Let's understand this thing, transition point. Okay, I am just giving a rough idea of this thing. Say what is the first order phase transition. In the first order phase transition, the Gibbs free energy G is a continuous curve. Okay, you have to remember these curves are asked in questions. G is continuous, G prime is discontinuous. Okay, and G double prime, these are the first derivative and this is the second derivative. Okay, diverges diverges means I'm giving it tends to plus minus infinity. Okay, tends to plus minus infinity, that means going towards plus minus infinity. So making a curve of these three things, say just wait. Say this is the curve of G and here is the temperature. Okay, this curve will look like this. Okay, this is the, just wait, this point is called the transition point. transition point, and the temperature at transition point is written as, say, Tp. Okay, Tp. It's not Tp writing it. Say something, some temperature, say T, say any temperature. This is the transition point, not writing it has certain energy, it will have certain energy. This is called a kink. Kink means a bump here. Okay, this bump. Continue. So this bump can be here or cannot be here. Okay, this is not a essential bump. Okay, so I am writing here that G is continuous, can have a kink, can have a kink. Okay, it does not necessarily mean that it will surely contain a kink here. Okay, so can have a kink. I am doing a graph of G prime versus T. Here will be a G prime. There is this continuous graph. How this continuous graph look like? Say you have the transition point here, transition point. Okay, discontinuous. Discontinuous means according to transition point. Okay, about transition point. Say the graph will look like. Say this graph should have like this position. Okay, but it does not. It does not resemble with the graph. There is a break on the graph. This break on the graph at the transition point. Okay, at the transition point is the graph of discontinuous graph of G prime with respect to T. With respect to T. Okay, this is the discontinuity. Here is the discontinuity of the graph. Now I am giving the G double prime graph, that is diverging. Just 1 second. Say this is the graph I am. G double prime graph. The graph, make the graph steady. Okay, say this is your transition point, and at the transition point there will be a straight line. Diverging means like this, and like this. This is called the diverging graph. Okay, plus minus infinity means say in this direction you can have a minus direction, minus infinity. In this direction you can have a plus infinity direction. Okay, this graph is going towards these directions. This is the temperature scale, and in the G double prime scale you can have a plus infinity here, and the graph is going towards plus infinity, and the negative side this graph will go towards minus infinity. That is, that graph is going towards minus infinity. Okay, this is the meaning of this tends to plus minus infinity. Okay, I think it is correct. So the example is what I am giving, some example of first order phase transition. Example is directly solid to liquid graph, solid to liquid transition, solid to liquid transition is a standard example of first order phase transition. Okay, first order phase transition, and also liquid to vapor. Liquid to vapor, you have to remember this thing, liquid to vapor transition, but not at critical point, not at, this is important point to remember, critical point, make it important symbols. This is also a first order phase transition, but excluding the critical point. Say you have one graph on the earlier section that we have drawn a graph, that this graph, this is the critical point, this is the critical point. Say this is the critical point. Excluding this critical point, say from this point, from this point, from this point, from any point, excluding this critical point, the liquid state can go to the vapor state, and the vapor state can go to the liquid state. Okay, excluding this point there will be a first order phase transition, but including this point, that means at this critical point the phase transition occurs, and the phase transition is called the second order phase transition that will be discussed later. Okay, so this is the example in which solid to liquid and liquid to vapor. Okay, these are the examples of this. So this is the first order phase transition. Okay, now I am moving to the second order phase transition. The next point will be second order phase transition. Something happening on the critical point is called second order phase transition. Okay, this is sometimes this is called continuous phase transition. Okay, continuous phase transition. Just one second. Yeah, continuous phase transition. In this case, our Gibbs free energy, I'm not writing the definition. Okay, Gibbs free energy as continuous. Okay, the graph of the Gibbs free energy is continuous. Say you have graph like this. Say this is the critical point. This is the triple. Sorry, this is our. Um, just one second. Transition point. Sorry, I have forgotten this thing. This is our transition point. This is in this transition. It will be a straight line. Okay, it will be a straight line. This is our transition point, and in this transition point, you can have a graph like this. This is the continuous graph of zeroth order Gibbs free energy. This is zeroth order derivative. Okay, the first order derivative of Gibbs free energy is also continuous. Okay, is also continuous. No kink in the Gibbs free energy direct. Okay, no kink. And in the first order derivative of the Gibbs free energy, there can have kink. Continuous. The graph of this is G. Say I am drawing the graph of G prime here. This is G prime. Here is a temperature scale. Say here is a temperature scale, and this point is called the transition point. And according to this transition point, there will be. I'm showing this is continuous, so this means this is the required kink. Okay, this is the kink. Write it carefully. Okay, this is the required kink. Okay, this is G prime, and now can I have G double prime? G double prime, and here it is a G. So what is our G double prime? This is transition point again, and according to transition point, what is G double prime here? I am writing G double prime here. G double prime is discontinuous. Okay, remember these points. Discontinuous. So what is discontinuous? A discontinuous graph will look like this. So this is this, and this is the graph is broken. The broken graph is called discontinuous graph. Okay, so I am making some examples. What are the examples? Liquid to vapor. First example will be liquid to vapor at critical point, which have been excluded on the previous first order phase transition. Okay, at critical point, this is the liquid to vapor and vapor to liquid. Okay, the opposite will be also acceptable. Normal unmagnetized state to magnetized state. Okay, magnetized state is also an example of second order phase transition. Okay, ferromagnetic to paramagnetic. and paramagnetic opposite is also acceptable. Okay, ferromagnetic and paramagnetic. Here it is a normal to superconductor. Normal state, superconducting state. uh, Orthohelium to perihelium. What is orthohelium to perihelium? I don't know about these things. In benzene we have taught that, say, this is ortho position, this is para position. Okay, orthobenzyl alcohol, parabenzyl alcohol, anything, the alcohol. No, I think do not know. I am not an expertise in chemistry. Okay, I don't like chemistry so much. So these are the examples of second order phase transition. So this is the ending of the statistical mechanics lecture series, and we'll be moving on as in on some questions or some different topics on the next lecture. So thank you for supporting us on the statistical mechanics lecture section, and keep supporting, subscribe the channel, like the video. Thank you.